This is the Architect Exam Podcast, the official podcast of the Young Architect Academy.
Hey everyone, welcome to the Architect Exam Podcast. I'm Emily, and today we're diving into a topic that comes up repeatedly on both the ARE and the CDT exams. This is quality assurance and quality control, also commonly called QA and QC. This concept appears across all ARE exams in one way or another, but you'll specifically encounter it on the practice management exam, specifically Objective 4.2, and again with project management section 5. And for those of you who may be preparing and studying for the CDT exam, these concepts are woven throughout the entire exam. Understanding QA and QC isn't just about passing exams, though. It's fundamental to how we practice architecture and deliver successful projects. This concept is something I repeatedly emphasize with our ARE bootcamp participants since it appears across all ARE exams. Today, we'll break down these concepts, explore how they apply throughout the project lifecycle, and I'm going to give you some practical examples that will help you on exam day and also in your daily practice. So for the next 15 to 20 minutes, we're going to go over what QA and QC actually means and how they work during design and construction phases, and the roles that different parties play throughout the quality process. All right, let's get started. We're going to start with just understanding the basics. Let's get clear on what these terms actually mean because they're often confused and they're used interchangeably and they really shouldn't be. So let's start with quality assurance, or QA. QA refers to the planned and systematic processes that provide the confidence that a project will satisfy the established quality requirements. QA is about a preventative system. It focuses on establishing procedures, standards, and protocols before a problem can occur on a project. So for quality assurance, examples include review protocols, checklist, creating standards, and following these during the design process and creating these design procedures. Now, quality control, on the other hand, or QC, is about monitoring specific results to determine if they comply with quality standards. QC is focused on the detection and correction of problems. It's about identifying when something doesn't meet the requirements and then fixing them. So some examples of quality control are testing, inspections, and verification activities. So this is coming after the fact. And a nice little trick that we like to throw in here, which is something that's really helped me throughout the studying process, to remember which comes first, meaning how quality occurs as a preventative measure. Remember that quality assurance, A, begins with an A, comes before C, quality control, starting with the C. So quality assurance is preventative and happens before a problem occurs. So just think, what happens first? What occurs first? The letter A, assurance. And then now quality control comes after, starting with the C. It happens after a problem is detected and then needs correction. So we always like to share that little tip to help you remember which comes first, A before C. Let me share some analogies that might help bring this message home. So for example, think about cooking a meal. Quality assurance would be following a recipe and having all of your ingredients measured and prepared before you even start cooking. It's the planning stage. And alternatively, quality control would be actually tasting the food as you cook, making sure it's properly seasoned, and adjusting as needed during the cooking process. Another way to think about this is a road trip. So consider you're planning a road trip. Quality assurance before the road trip is mapping out your route, checking your car's conditions, and packing supplies before you leave for the trip. And quality control is monitoring your gas levels during the trip, checking the GPS to make sure you're still en route and on track, and adjusting your plans if there's, any kind of change in the road or bad weather. And another analogy to help you understand the difference between these two and the importance of the two is think about your health and the quality of your health and maintaining your health. QA is a preventative health measure when it comes to your health. Consider exercising regularly, eating well, and getting routine checkups. That would be QA. QC would be, let's say you get sick and you have symptoms. You would be monitoring those systems and maybe going to the doctor, getting tests and treating a specific issue. So it would happen after. That's QC. And of course, my personal favorite analogy that I want to use today is a gardening analogy. So QA is like preparing your soil properly for planting and selecting the appropriate plants for your climate and planning your watering schedules. And In terms of gardening, QC would be regularly checking for pests, pruning when needed, and adjusting care based on how your plant responds. So in terms of architecture and construction, QA and QC work together in what construction contract administration practice calls the closed loop system. QA is going to establish the framework that QC operates within. And then QC is going to provide feedback into improving QA procedures, and then the cycle continues. These distinctions between QA and QC are crucial to understand for the exam. In fact, Mike and I have written numerous practice questions about this. It's in our ARE 101 course. We also created our CDT 101 program that has a lot of questions regarding QA and QC that really helps to bring the message home and helps you to understand it. And in the PDPG, or the Project Delivery Practice Guide, the guide defines quality as the degree to which contract documents meet the project goals, objectives, and the intended purpose of the project. Quality isn't just about meeting the minimum standards acceptable. It encompasses 4 key imperatives, which are 1, fitness to use, 2, conformance to requirements, 3, meeting owner expectations, and 4, the quality of the project team itself. So next, let's relate QA and QC back to architecture. Let's talk about how QA and QC work during the design phase. Many exam candidates focus only on construction quality or quality management practices during construction, but we really need to be monitoring QA and QC early in the design process. So when we work with our ARE bootcamp students, I noticed many focus solely on the construction phase and kind of controlling quality at that point, but we really should recognize how quality management begins much earlier on. So let's look at this with quality assurance first, with the design phase. QA is beginning before design work even starts. QA can start when you're establishing design standards and procedures. I mentioned earlier, this is setting those standards. Maybe there's CAD standards, BIM standards, and it's creating these documentation protocols that sets a design team up for success, regardless on what project they're working on. So we, in the field, and many of us who work in architecture, we know a lot of firms that implement these principles, that have their set standards and have these checklists that provide a framework for our quality management systems in the design process. Throughout design development, QA includes coordination with consultants as well. We may meet with our consultants through regular meetings and have regular design reviews with them. That way, by having these meetings, we can make sure all of the items of our project are kept in mind across all trades. We also are going to ensure that our design meets code analysis through early code reviews, accessibility compliance checks, and constructability reviews. This usually will happen in-house, in the office. You're keeping all of these layers of information in mind while you're designing. And a critical aspect of the design phase in quality assurance is monitoring the consistency between the documents and the owner's requirements. This means often going back and verifying that the design that's being developed actually matches the program that was provided. And you may need to do this by conducting regular owner reviews and meetings to ensure that those expectations are being met. Now, let's talk about quality control during the design phase. QC involves structured reviews at each phase. So each phase meaning schematic design, design development, and construction documents. These reviews take various forms. There will be peer reviews, or maybe reviews with the principal of the firm, or even just getting someone else in the office that's not working on that specific project to take a look at the design documents and provide a fresh set of eyes on the drawings and on the design documents. These QC strategies are providing technical accuracy checks, and they're really fundamental for QC. So during these reviews, things such as verifying dimensions are looked at. You'll cross-reference information between the notes and the drawings and the callouts, and you'll cross-reference information between all of the documents and drawings. Another thing that happens during QC is value engineering. This is where you're looking at the cost estimate of the project and you're creating cost estimates at each design milestone throughout the design process. So this really helps to make sure that you're staying on budget and you're identifying any items that are actually not keeping the project within budget, and you can adjust accordingly. So QC is really these scheduled check-ins at each design phase. And these are milestone approvals and milestone dates that these reviews happen, and sign-offs need to occur on the design documents during these phases. These sign-offs are also, not only is it the peer reviews, but this also is when the owner of a project and your client will approve of the milestone of each phase. And so this creates a great accountability for the entire project, making sure that the quality is good and that it's on track and that it is in line with what the client wants. So we may see some examples of these various forms of QA and QC in firms and throughout the design process. Again, we're seeing these kind of comprehensive checklists and tracking logs, not only tracking for timing and schedule, but tracking of what items need to be delivered on the drawings and what information needs to be delivered at each milestone date. There are, again, CAD drawing standards and document templates that are used that you would inform and fill in with each project. There are also various quality management softwares that firms like to adopt and use to assure that they are meeting all the requirements of the project throughout the design phase. There's also BIM coordination and clash detection. This is great when coordinating with various consultants to make sure that everyone's layers of information work together. And there's various document management systems and review comment tracking. Think of sharing a marked up set, sharing a live PDF with everyone's comments from various members of the team. Everyone's able to weigh in and make comments on the decisions that are being made. The key takeaway here is that quality in design isn't accidental. It's the result of deliberate systems that are in place and these verification steps to make it happen.
You're listening to the Architect Exam Podcast, your guide to passing the ARE.
Hey, we know you're probably listening to this podcast while commuting to work, at the gym, or tackling other tasks. So don't stress out about writing things down or taking notes. Because after we wrapped up this episode, Emily sat down and carefully put together notes for this entire podcast and packed it all into a simple, ready-to-print 2-page PDF study guide. So swing by youngarchitect.com/quality to grab your free study guide. All right, back to the podcast.
Next, let's talk about quality assurance and quality control in terms of the construction documentation phase. So as design starts to transition into construction documents, QA and QC become even more critical. This is when the rubber meets the road. Your documents need to really clearly communicate the design intent and technical requirements to the builders who will actually be physically building this project. So while we were developing our CDT 101 course, we put a significant emphasis on the documentation process, since these are really critical to the project's success and what actually gets built. So for quality assurance during the document production phase, we're doing something similar to what we did during the design phase, but this has that layer of technical information on it. So you're still using your CAD standards, your checklists, and your protocols, and you're following those drawing standards, but now you're layering in the technical and engineering side. You're also applying these standards to technical specifications and the coordination of those items into the drawings and the design. It's essential. You need to assign every component of a project and a building into each specification division and really define in detail what needs to happen with each item and each material. So during the construction documentation phase, you may be assigning responsibilities to who does this, who creates these technical specifications, and then holding specification coordination meetings with the team and with consultants to ensure that everything is working together. These regular coordination meetings between all the disciplines, they happen through, again, these BIM coordination sessions. You're really looking for any conflicts and you're checking that everything is working cohesively together. And the drawing production and the sequencing of that establishes a standard approach to what drawings actually get put on the sheets. And this really identifies a critical path for the completion of the 100% completed construction documents, right? So design isn't happening at this phase. This is now you're taking that design and you're curating it to actually be constructed. So all of those additional layers of technical information are now getting informed and coordinated and checked into the set. So again, this is checking your structural components against the architectural components, and then layering in mechanical, electrical, plumbing, even the site and civil components. All of these need to now be coordinated, checked, and reviewed in the set to make sure there are no conflicts, and you're assuring that those items work together. So this needs to happen before these documents are issued and handed over to a construction team to be built. This is really the final moment of quality control with the full set of drawings. The final bid document review before you hand over this set of drawings is one last check for completeness before issuance. So all of this may seem very tedious. There's a lot of cross-referencing and checking, but it's essential to minimize errors and omissions that might lead to just a long road of RFIs from contractors later, or maybe even change orders if there was missing or confusing information. Worst case scenario, it could become a claim during the construction process. You're really monitoring all of these steps and all of these items together before you hand over that set of drawing. And then quality assurance and quality control also happens during the construction administration phases. So this is when construction has started and your role as the architect or as a project manager, you're monitoring construction and you want to ensure that the physical construction that's happening aligns with the design intent that was initiated before. So once construction begins, QA and QC transitions those documents to the physical building. Quality assurance during the construction administration phase starts, first of all, with a pre-construction meeting. So this is the point where you are going to meet with the team that will be physically building this project and this building to review quality expectations, review submittal requirements and procedures, and review testing and inspection requirements. So you're not waiting until these things need to happen to communicate and hear from the construction team. You're setting that expectation up from the beginning. And that's quality assurance. It's before construction starting. You're setting that expectation of the communication you expect from the contractor. The submittal review procedures, that's going to ensure that the materials and the systems that are being installed on the project will meet those design requirements before they're ordered or installed. Even the submittal review is another form of quality assurance because it's happening before it's installed. RFI management, a request for information, that provides a systematic approach to answer contractor questions that may come up during the document review as they're reviewing the documents and preparing for construction. You may also set up protocols for site visits and field observation procedures and create a structure and a checklist when those site visits need to happen so that you have a criteria to fill out on each site visit. And that way you don't miss any category, so you're setting up your documents that you will essentially fill out when there is an RFI or when there is a site visit required. You're setting yourself up for success by having a protocol in place before those happen. There also may need to be some templates and standards set up for any documentation of non-conformance. So let's say you go to the job site, you go to do a site visit, and you see something that is not in compliance with what the design intent was. You'll create a template or framework of a formal process of how to respond to that. So now quality control, which is happening during construction has started and you're responding appropriately to what you're observing. This is going to focus on the verification of activities. So this is testing and inspection of installed materials and building components. These tests are being scheduled, and now you are monitoring the result of these tests. It's also material verification, which will confirm that the products installed match those submittals that were given to us by the contractor and also matches the design intent. Quality control is also verifying the installation procedures, allowing for correction if there is any issue seen of an installed material. And it's the ongoing verification of conformance to ensure that the project is being built exact to the contract requirements. So project closeout too, as you near the end of construction, is also a form of quality control. This includes punch list development and resolution, system testing and commissioning, and the final acceptance and the procedure for the client to actually finally accept the final project and product and move in. Those are all quality control procedures. So It's kind of easy, I think, to think about quality assurance and quality control in terms of construction because you're thinking of the protocol and standards in place before construction even starts, which is quality assurance, and then all of the activities that are happening during construction, checking everything that is done correctly and to the expected requirement and conformance, that's quality control. So now let's talk about who is in charge of quality assurance and quality control. Who's responsible for this process? So let's start with the architect and the engineer. The architect and engineer, they're going to establish the quality standards in the contract documents. They're establishing the expected quality. So they will implement design quality assurance and control, again, through those reviews and submittals for conformance. They're creating or they're encouraging these opportunities for review and then creating those templates for conformance that can be filled in with project information as it's available. Architects and engineers are also conducting site visits and field observations, getting their, feet on the ground and eyes on the site to just observe and monitor what's going on is actually in line with what was specified. And the architect and the engineer, they have the authority to reject any work that's non-conforming to those design documents. However, there are very important limitations to specify. Architects don't actually monitor and specify the means and method in which the work is completed. They are not on site continuously doing inspections, and they are not physically putting this building together themselves and working with the team directly to make sure it happens. They are observing and monitoring, and it really is the contractor's role to come up with the means and methods to achieve the expected design intention of that project. So speaking of the contractor, in terms of QA and QC, the contractor is responsible, again, for the means and methods. That includes supervision and coordination of the work. They are also choosing their subcontractors and managing the quality of their work. They will also curate the materials to the site, the handling and the storage of the materials and building components. And they will also be part of the pre-construction and pre-installation meetings before these items start to physically take place. So they are able to verify the quality of the installation by being responsible for those means and methods. And the contractor is performing self-checks on themselves and their teams. They are setting up their inspections and the schedule for those inspections since they are installing the work. And they need to be correcting any work that's found to be non-conforming. So if the architect and engineer comes in and says this is not conforming, the contractor is responsible to correct that work. They are also responsible at project closeout to resolve that punch list item or resolve that any items that may be on the punch list that need to be corrected before owner moves in to the project. And speaking of the owner also plays a role in QA and QC in that they are establishing the project goals and the project requirements. So this really defines what the expectations are of the final built project. So the owner has a lot of responsibility to the design team and the construction team to be very clear about what those expectations are so that we can successfully deliver that vision. So the owner may engage with, if there's a need for a special item or material or installation, they actually may engage with special inspections that need to take place and special testing agencies that might be required for a specific project or product type. The owner should also be involved with a commissioning agent and hire a commissioning authority since they will be taking over this building once it's ready to be moved into, and they will be monitoring the building systems and mechanical, electrical, and plumbing. And since they're moving into the building, they really are the agents of this building after construction completion, and they should know how to monitor and manage that building successfully for many years. The owner may also weigh in on and make decisions on any non-conforming work. They may accept work that's non-conforming, but still meets their design expectations and the performance expectations. And they are also involved with the post-occupancy evaluation and, again, building commissioning. So understanding how the parties of a project play a role in QA/QC is really important, not just for the exams and understanding the ARE and CDT exams, but really at your role on the team for a construction project. So while taking the exams, you may see questions that often focus on who's responsible for a specific quality task. So just be sure to understand the difference, what the owner does, what the contractor does, what the architect, engineer, and design team does, because understanding these distinct roles It can be particularly challenging kind of memorizing each one. Try to put yourself in the shoes of each role of each team member and how they inform the project and how they ensure quality assurance and then following up with quality control.
You're listening to the Architect Exam Podcast, the official podcast of the Young Architect Academy.
I want to give you a real life example of this, a real life architectural example of QA and QC to really bring in this message or really bring this message home. So let's use the example of a curtain wall system and following a curtain wall system through the QA and QC process to see how it works in practice. So during design, QA or quality assurance is going to establish performance expectations and performance requirements of a curtain wall system. So this will be based on a building's climate zone, a building's occupancy type, and of course, the design intent of the building owner. And then quality control, QC, is actually going to review that the system that is going to happen, the curtain wall system will integrate properly with the rest of the building, such as structural elements and even energy requirements, right? So the curtain wall system is one part of the entire building, so it has to work with the rest of the building. So quality control during the design reviews is what's going to ensure that the curtain wall system will work throughout the building as a component of the building. So that's QA and QC during the design phase of a curtain wall system. But during the documentation phase, the construction documentation phase, quality assurance is actually going to ensure that the details are developed and coordinated with all of the trades and consultants to make sure that the installation of this will be proper. And quality control is going to take place after those reviews and coordination meetings take place to give that drawing set one last look and one last final review to make sure all items are coordinated and technically sound before it's turned over to the contractor for bidding and for construction. So during the procurement phase for QA and QC, this is when you're going to start looking at the submittals for that curtain wall system. You're going to review the submittals to confirm that they meet the proposed system requirements. You may even request mock-ups and test results to verify the performance of that curtain wall system. And this happens before that full curtain wall system is installed into the building. So that's quality assurance. That's happening before. You're making sure that that system specified is going to work for the building and for what is needed. And in construction now, during the construction has started, there will be pre-installation meetings of that curtain wall system. You're going to ensure that the installers that are actually putting this system in place understand those original requirements that took place maybe many months or many years before. So this may be a check they may put up one panel of the curtain wall system and there may be a check of that first panel. It may receive extra scrutiny just because it's the first panel that's being installed. And then there will be ongoing checks of quality throughout the installation to make sure that it is meeting the requirements. There may even be like hose testing, water testing, spraying down that curtain wall system to make sure it's, airtight, watertight. And that final acceptance is going to verify that the item is completely installed and accepted. So that's quality control that's happening during the construction process. So this curtain wall system, that's an example of how QA and QC is continuous throughout a project, not only with each phase, design, pre-construction, construction, procurement. It can be broken down even further into each building component. So you could really break this down into any phase of a project in a building. And if there's any areas where there's an incomplete specification or an inadequate review, it's going to really affect the rest of the building and project process and phases. And that could negatively affect the final quality of a built project. So QA and QC is really a continuous cycle through all phases and through all components of a construction process. Okay, so a lot of us are here today because we're studying for the ARE exam or maybe the CDT exam. So I want to relate to why QA and QC is really such an important message for these exams and what to kind of expect and some tips on exam day in regards to QA and QC. So to bring that message home, really understand the difference between QA, QC. The QA is before, it's quality assurance, it's preventative versus quality control. letter C, after control, is a detection system. So you're looking for problems, you're detecting problems, and then you're fixing them. So think of quality assurance as a system in place, and then quality control as a verification. And secondly, know the roles of all of the team players of a project and their responsibilities in regards to QA and QC. This is something that you may see on your exam. Who does what? Who's in charge of what? And, us as architects or soon to be architects, we want to know what our roles and responsibilities are. But of course, it's very important to understand what the owners and the contractors and all team players' roles are with QA, QC as well. Also, keep in mind and recognize how QA and QC apply throughout a project's life cycle, from the initial design and schematic design, early phases of design, all the way throughout construction starting and project closeout. And last, understand the importance of documentation and communication throughout the quality process. This is with design, this is with your consultants, this is with contractors, communicating with their subcontractors. Documentation and communication is crucial for the success of a project. So again, in terms of the exam, think of, there may be a scenario that has a question that asks you who is specifically responsible for a task that they may give you an example of a task and ask you who's responsible. They may give you an example of a process that needs to take place, like a punch list. Who's responsible for that? And be prepared to have the appropriate response, at hand as to who addresses what in terms of quality issues. Remember that quality management isn't an isolated activity. It's not one or the other. It's integrated into all aspects of project delivery, and it is a cycle. QA and QC work together as a continuous process and cycle to better inform each other and to achieve quality requirements for the project and each of its components. And finally, there's a lesson here about the architect's registration exam. Let's really bring this close to home with this message. So think about the ARE, think about taking the exam. A lot of us, including myself, have taken the exam and the various divisions through a trial and error process. You'll take an exam, you'll figure out what you don't know, and you'll have to retake the exam. This kind of approach of just jumping in and trying to get it right is a kind of reactive approach, really. It's a quality control approach, which essentially is you're starting maybe without standards, protocols, or templates in place, and you're just hoping for the best result. We don't want to do that with our exams, the same way we don't want to do that with our construction projects. We don't want to just approach our goals with a quality control approach without quality assurance. So, at Young Architect and working with ARE boot campers in the ARE bootcamp, we've built our entire curriculum around quality assurance principles. We really aim to encourage good study habits, establish those habits from early on in the study process. In the beginning, we communicate and really create realistic exam schedules and expectations of that schedule. And we really encourage a proactive learning style, and we teach a proactive learning style based directly on NCARB's objectives, straight from the source, which helps you taking the exam, which helps you studying for the exam, get it right the first time. So rather than approaching these exams and just retroactively trying to understand what issues you have, at the ARE Bootcamp and with Young Architect, we set up the quality assurance protocols and template in place and checklists so that you can do it right the first time and have a lot more confidence going into taking these exams and have less of a reactive approach. So when you're thinking about QA and QC principles in terms of construction and design and your built projects, you can also think about just taking the ARE exams with the same mindset. The same QA and QC principles that build better buildings can also build better architects. I hope this overview of QA and QC helps you in your exam preparation, but also in your professional practice. And if you're studying for the ARE or the CDT exam and you need more comprehensive resources and all of that quality assurance I was telling you about, please visit academy.youngarchitect.com. You're going to find a complete collection of all of our courses and programs. They're designed specifically to help you pass these exams the first time.
Thanks for listening to the Architect Exam Podcast. Ready to take your studying to the next level? Visit our online ARE Architecture School website at academy.youngarchitect.com to learn more about how we can help you. See you next time.